Water. That's the key ingredient. But just what type of water? And how exactly does its chemistry affect how tasty our coffee is? Let's take a look. The problem in the 98%. When you drink a cup of filter coffee, you're taking in roughly 98.5% water. Espresso is about 90% water. The Specialty Coffee Association dictates that perfect brewing water must hit a target measurement of 150 parts per million, meaning, if your tap water is too pure, it acts like a blind solvent, which gives you a cup of under-extracted coffee. If your tap water is too hard, however, meaning it's already packed with aggressive mineral ions, it's going to violently over-extract the coffee, pulling out bitter, dry, and heavy compounds. It's not really just about the total volume of minerals, but it's about exactly which minerals are there floating about. The molecular magnets. In 2014, computational chemists proved just how water extracts flavor on the molecular level. Coffee flavor compounds like citric and malic acids that taste like bright fruit and berries carry a bit of a negative electrical charge. The minerals calcium and magnesium are divalent cations. That means they carry a positive 2 electrical charge. When heated water slams into the grounded coffee, the positively charged magnesium and calcium act like microscopic magnets. So they end up grabbing onto the negatively charged flavor compounds and violently rip them out of the coffee cell walls. Magnesium is highly specific. It targets bright, fruity organic acids. If your tap water doesn't have magnesium, it's impossible to extract those fruit profiles from the bean. You're essentially pouring a blind solvent over the coffee and hoping for a miracle. The alkaline buffer. While calcium and magnesium are responsible for pulling flavor out of the beans, you also have to control the incoming acidity. Coffee naturally contains massive amounts of acid. This is where bicarbonate comes into play. Alkalinity is a crucial buffer. If your brewing water has zero alkalinity, the cup will taste aggressively sour and sharp, like battery acid. But if your water has too much bicarbonate, it instead acts like a blanket, neutralizing all the vibrant tastes in the coffee. This makes the coffee taste flat, with no character. Finding the right balance between the molecular extraction magnets, the magnesium and calcium we talked about earlier, and alkaline buffers is the secret sauce of high-quality coffee. Reverse osmosis. All this chemistry is why premium cafes don't trust basic carbon water filters. Since municipal tap water varies wildly from city to city, and also totally shifts with the changing seasons, cafes cannot rely on what crawls out of the pipes. Rather, they use reverse osmosis systems. This process physically forces tap water through a microscopic membrane, stripping out 99% of all minerals, chlorine, and contaminants, dropping the total dissolved solids down to 0. But, like we said, you can't brew coffee with 0 mineral water. It tastes terrible, and it will ruin expensive espresso machine boilers by leaching the metal out from the hardware. So instead, the cafes use a bypass valve to inject a calculated dose of pure liquid calcium, magnesium, and bicarbonate straight back into the water line before it ever gets to the machine. Historically, this level of water profiling was only found in commercial cafes because industrial reverse osmosis setups cost thousands of dollars. But this exact process has recently been given to people right at home. You don't need a massive filtration rack to get this level of perfection in your extraction anymore. All you need to do is walk into your local grocery store, buy a $1 gallon of pure distilled water, and drop in a pre-measured mineral capsule from companies like Third Wave Water. These packets have the exact ratio of magnesium sulfate, calcium citrate, and sodium bicarbonate needed to hit that ideal standard. It transforms flat grocery store water into a certified grade A coffee extraction solution. Before you drop $1,000 on a new grinder or espresso machine, make sure your solvent is ready to go.